Hello, everybody, and welcome to today's webinar, How to Spot and Stop 5 Common HVAC Failures. My name is Megan Billingsley, and I'll be your moderator for this session. Today, we'll be discussing the bane of many facility managers' existence, the comfort call. HVAC issues make up the majority of service calls, and as you all know, any downtime for stores or restaurants is disruptive and costly. Remote facilities managers without eyes on the ground must try to diagnose issues from secondhand information. To resolve the issue quickly, they'll often dispatch a technician or roll a truck, no matter how simple the fix may be. For facility staff on the front line, diagnosing an HVAC issue is also a headache. At the end of the day, more service calls means more time and resources taken away from other facilities management priorities. In this chat, you'll hear from two HVAC experts on how to turn a facilities management strategy from reactive to proactive. Then we'll run through 5 common HVAC issues, their early warning signs, and what preventive maintenance steps you can take to reduce their occurrence. Before we begin, I have a few housekeeping items. The slides will advance automatically throughout the presentation. To enlarge the slides, click the Enlarge Slides button located in the top right corner of your presentation window. If you need technical assistance, click on the Help widget located on the bottom left corner of your console. We encourage you to submit questions at any time during the presentation using the Q&A widget at the bottom of your console. We will try to answer questions during the webcast, but if a more thorough answer is needed, or if we run out of time, we will answer it later via email. Please know that we do capture all of your questions. Finally, we are recording this webinar, so you'll be able to access the recording on demand using the link from today's event. And with that, I'm thrilled to introduce our two HVAC experts. We have Andrew Gajcik and Gino Passarelli. So to kick things off, each speaker will share a little about themselves and their HVAC expertise. Andrew, would you like to start?
Thank you, Megan. So I've been in the HVAC field for about 35 years, so quite a long time. Where I gained my practical and field experience was 10 years installing and servicing commercial industrial HVAC equipment. Of those 35 years, I spent really last 16 years in the smart thermostat industry. And really the latter part of that time spent in the industry, I spent more time on the commercial side of smart thermostats, really focusing on helping clients maximize the benefits of remote HVAC management and diagnostics.
Wonderful. Thank you, Andrew. And Gino.
Perfect. Thank you. Yes, I also have 36 plus years of hands-on industry experience. My career started out in the field as a service technician, and currently the last 12, I've been vice president of service with the company that I'm with now. And our company specializes in preventative maintenance and the ability to customize it to meet facilities' needs. That's it.
Thank you, Gino. So now that we're all friends, let's dive into the topic that we're all here for. I'd like to talk about the scale of this issue. How common are HVAC failures, and what's the actual impact of these frequent breakdowns? Gino, what are you seeing in the field?
Got it. A large portion of the work orders that we are coming across are issues with no heat, air conditioning, refrigeration issues, things of that nature. And what we're finding is that we're getting these calls based on a more of a reactive than a proactive need, which I'm more on the reactive side of things. The costs are inflated at a much higher level, and the need to get things up and running at a much faster pace, which obviously costs more money. A lot of issues that we're coming across can be prevented by taking that proactive approach as far as a well planned out maintenance program.
Andrew, any thoughts?
Yeah, so I think really beyond the numbers as well, you have to also consider the impact on the customers. I do have the opportunity to speak to many FMs throughout, working week. And so far what I've seen, during my tenure at MISA, I mean, the business is going to continue. The store or restaurant is open, HVAC system goes down. I mean, it's business as usual, but you're going to end up with unhappy customers, unhappy employees. When you think about, when somebody's walking into a retail store and it's really uncomfortable or hot or cold in there, I mean, what is that retail experience going to be like, or that shopping experience going to be like? It's not something that would be, something that could be avoided. I put myself in the shoes of a customer, walking into a restaurant, for lunch or dinner. Do I want to feel uncomfortable, hot or cold? I mean, of course not, right? So, I mean, comfort is going to be really important, for the business, for the operations, and should be top of mind for them.
Yeah, one interesting statistic that I did come across is that even a 2 to 3 degree swing in comfort temperature in a retail space could affect sales by 10 to 20%. And that was an article I read not long ago. And when you look at nowadays with social media and things of that nature, nobody wants a bad reputation for having an uncomfortable restaurant or store or facility. So I thought that was a pretty interesting statistic.
Yeah, as you're saying that, I'm thinking of the one store that I always go to that's always freezing, so I have to bundle up in advance. And it kind of sounds like it could be a nightmare for everyone involved. So why are HVAC failures so common? Gino?
I would say the number one reason that we come across is a lack of preventative maintenance. Either we find that none is being currently done at all, or if there is a plan in place, it's not being done thorough enough. I would say that those are probably the two top reasons that we've come across.
Andrew, what are you seeing?
Yeah, I think there's a few factors that I can think of. Just recently, I'm working with another client, and right now, he's overwhelmed with work, not just HVAC issues, but all kinds of issues when you're managing, a portfolio of hundreds of sites. So I think the larger the portfolio of sites and locations, it becomes harder to manage those sites individually. And also factoring in when you don't have any visibility into the HVAC equipment, it just makes it much more difficult. I also believe, there may be a lack of investment on the operating side of the business. It's as much as we know preventive maintenance is important, it's also a cost to the business, and ROI itself is likely to not produce the short-term or immediate financial benefits that they're looking for. Also think maybe staffing or resource gaps could be an issue, which could certainly lead to escalating problems when things slip through the cracks or go unnoticed. I think a lot of FMs can probably relate to this, but they are running a very bare bones operation, very minimal staffing. Sometimes it can just be simply a one person, show, and then it's very easy for things to get missed. So I really think, in summary, as a business expand their real estate portfolio, are they expanding maintenance budgets to really mitigate that potential disruptions to their operations?
Gino, you mentioned preventative maintenance as well. Any thoughts that you'd like to add here?
Yeah, it's a hard thing to track, to keep track of as a facility manager, FM. Because generally the equipment's either on the roof, it's unseen, or it's hitting above the ceiling and things of that nature. And really the only piece of equipment or device that they deal with is a thermostat of some sort. And generally, if they have multiple units, they might have multiple devices or thermostats. And it's generally the last thing that they think about. So being able to be as proactive as possible and try to get that, to think at least more proactive would benefit the facility, along with ease the mind of not only the customers, but the facility managers.
I also think, for facility managers, having, a consistent HVAC contractor, somebody who is familiar with the history of the equipment, performance, et cetera. I've seen that a lot where, a company, for whatever reasons, they've switched contractors or have had different contractors working on equipment over the years, and not necessarily, and I know from experience, coming into a piece of equipment and, not knowing what has been done, or I've seen alterations that really something I don't think it was done correctly. So definitely, having that consistent HVAC contractor who's servicing equipment is going to be important. They, can provide that maintenance, complete maintenance solution. They can provide recommendations, to really help make that piece of equipment last, or make recommendations, when it's probably advisable to think about, planned upgrade. And so, really equipment itself doesn't have that infinite lifespan. Components do wear out. And so it's really, trying to do everything planned as much as possible, make those changes or those updates or fixes before it becomes an emergency.
Yeah, and I could agree with that. And to add to that, especially the history of what is being done on each individual unit is extremely important. When you look at ASHRAE standards, which is the industry standard for the typical life of a simple rooftop, is approximately 15 years. And what we found through proper maintenance and doing the things that manufacturers expect to be done on their equipment throughout that lifespan, you could very easily get 20, 25, and in some cases 30 years out of that life of the equipment. So in the consistent HVAC contractor is extremely important, because they could track those costs, those maintenance records throughout that lifespan, to be able to educate the facility managers or the owners and budget appropriately for the future.
And I also think it's not just about the incidental cost, but you should really also consider things like, interruptions to the business, or the potential for lost customers, or, again, inventory, for a restaurant. So definitely it can be costly incidentally, but also, it can impact your, the business in regards to your customers and operations.
Yeah, really great insights, especially just the point about having someone who is familiar with your equipment, kind of that consistency that you were speaking to. And every facilities manager has had that oh no moment, the call from a store that's sweltering or freezing. And you've highlighted how investing in preventive maintenance can pay off in the long run. How else can facilities managers start to flip that script and reduce the frequency of HVAC emergency calls? Andrew?
Sure. I'll reference MESA HQ. So MESA HQ itself, it's really a two-component solution. So obviously the thermostat hardware is what controls the HVAC system, but it also uploads the runtime insights into the cloud. Then we have the MESA HQ web platform, and this is what the clients are working with or navigating to manage that portfolio of thermostats, whether 100 thermostats or thousands of devices, it doesn't matter. Typically an EMS solutions can provide features or the ability to, for example, monitor indoor air temperature, humidity, whether stores, restaurants, or really, any commercial space for that matter, or even inside commercial refrigerators. What I like to see as well is, you can see the response time and how the HVAC system is achieving set points with regards to outdoor climate, or even for that matter, determine, the building efficiency, how quickly does a building heat up or cool down when the HVAC system itself is not running. So it does provide those kind of insights. You can also see how the HVAC system recovers from setbacks. So this is where people or businesses are going to save energy during the setback periods or unoccupied periods, but how quickly does that HVAC system recover from a setback period? And a lot of that, obviously then shows, the performance of the HVAC system itself. When we look at runtime reports, it does help, compare baseline operation against other units and help you understand the performance of the HVAC system. You can detect or see abnormalities or changes that change over time, indicating potentially a failing part or dirty evaporator coil or unplugged filter. And with remote management, it really helps you prevent excess wear and tear by keeping, set points in check and using setbacks during unoccupied periods. When you have that visibility, you can really better understand the HVAC system, how it's working, what components are potentially degrading over time, and if something that's not, something that was working fine yesterday may all of a sudden not be working correctly today, and you can see that, from based on the runtime reports. Definitely, as you build out your portfolio and you have thousands of thermostats connected online, you want to be alerted when there is going to be an issue. So having those real-time alerts helps you kind of narrow down to take proactive measures. And you can see at that point then, are you getting temperature swings or it's not meeting set points? And then what I also mentioned to field manager, or I'm sorry, to facility managers is, the data that we see in the runtime reports, that's something, those are insights that you can share with the technician as well. I know, if I'm going on site and I get that extra little bit of intelligence, knowing what is happening as a technician, that's going to already allow me to kind of maybe narrow down what the potential problem is with the HVAC system.
Yes, it sounds like visibility and control then are becoming the new superpowers for facilities teams. But from what I'm hearing, in order for FMs to leverage these powers, they need to have a baseline understanding of common HVAC issues to make informed decisions. As the HVAC experts, you shared with me earlier the 5 troubles you see most often in the field. So I'd like to now dig into how FMs can spot them before the problems escalate, or ideally stop them from happening in the first place. We'll start with the most common source of HVAC problems, the compressor. On the slide, you can see a couple reasons why compressor fails. So Andrew, what are early warning signs that facilities managers can look out for?
For sure. So, typically a telltale sign of compressor failure is, the whether heating, if it's a heat pump or AC, you are going to feel that impact in temperature, whether heating or cooling. So this is where facility managers are faced with figuring out what the HVAC system is doing or why it's not working. HVAC components themselves are very highly integrated, so multiple issues may be occurring. Sometimes that what appears to be one issue may be a symptom of another failure. Compressor itself absolutely is the heart of an HVAC system, whether AC or heat pump. They can fail in many different ways. Warning sign typically, space not meeting set point temperatures, or you could be dealing with insufficient heating or cooling, even though the HVAC system itself is running. Compressor itself may be running intermittently. So when we look at this runtime report here, if you look at, for example, the indoor line, where I can see the temperature decreasing and increasing and decreasing over the course of a day, that's typically an indication that, a compressor itself may be overheating due to mechanical issues or electrical issues. And, these thermal overloads are kicking in, turning off the compressor. From a runtime perspective, the thermostat is comparing temperature versus set point, and it's calling for that air conditioning. And so you can see in that graph, on the first few cycles, you're getting normal intermittent operation, maintaining a set point, but gradually things are getting worse to the point where, compressors is simply not effectively running consistently, and therefore the thermostat is calling for that constant cooling because it's just never meeting set point. Some of the more obvious things, I believe, too, whether they will actually hear it or not, because all this equipment is on the roof, but you can hear grinding noise or constant clicking, very loud, abnormal mechanical sounds, hard starts. So, it can be very obvious if it's loud enough or if it can be heard, into the building. Technician, obviously on site looking at the equipment, he's going to hear that right away, know that there's going to be a problem. Depending on the type of failure, whether it's related to refrigerant charge, there could be ice forming on the refrigeration lines. And also, because it's not cooling, and never meeting set point, you getting that excessive runtime. So this would also likely, lead to higher electrical bills. When they get their, when they get that in the mail and they see how come my electricity is so high at this point, and so just simply because it's that compressor itself is a high energy consumption component, and is really the one part that can affect the overall system as well as energy consumption.
Gino, any thoughts?
Yeah, I agree with Andrew. From a FM standpoint, one item that could be addressed to take a proactive approach if the facility or the space, if you don't have the ability to view the set points, actual temperature in the space from one location, is to do a daily walk. Let's look at your thermostat, see if you achieve that set point and things of that nature, so you can catch if there is a problem before that problem becomes a drastic problem. The sooner we can catch issues that are occurring throughout the facility, the less cost that could be occurred through the repair. Secondly is, if you do have the ability to see and look at the equipment, it just from a visual standpoint, if you start to see coils dirty, filters dirty, things of that nature, that is not good for any type of unit. And like Andrew mentioned, that the compressor is the heart of the system. So it'd be no different than, you look at the heart and you're starting to get plaque and all that cholesterol build up. The heart's going to have a hard time pumping. It's no different with a compressor. And at some point, you will have a drastic failure of that component. And then when you look at the cost of a replacement of a compressor, then it could be high in some situations. So the more proactive we could be, from a visual standpoint, whether we're achieving set points, just the cleanliness of the units and things of that nature, could be a drastic help, and definitely help reduce costs.
Yeah, I think that's a great point. And it does make me wonder, how many FMs are actually cleaning the HVAC coils regularly? Gina, what can FMs do to help prevent their compressor from sudden failure?
It's being proactive, paying attention to obviously the set points in the space temperatures, and making sure that we're as close as possible. Using a product like MISA, where that makes that process much easier, because you're able to see multiple units, multiple equipment, multiple set points, and temperatures from one spot instead of walking a giant facility or space. And then it's the obviously the cleanliness of the units. It's the coils, the filters. A lot of rooftops for retail space, they bring in outdoor air, which means that there's an economizer component where you could utilize the cool or cold outdoor air to help cool the facility, making sure that is operating correctly. Things of that nature, I think, are the best way to go about it.
Andrew, any thoughts there?
Yeah, I think the reality is compressor failure can happen over time. It can be a gradual, event, or it can be immediate. I think really the best approach, as you were mentioning, is maintaining the system overall. Even though the compressor itself may be functioning well, having dirty condenser coils, for example, is going to stress that compressor and just reduce the overall lifespan of it. So maintenance is going to be definitely important for sure. And I think, when maintenance is being done, again, having that consistent contractor on site, somebody who's familiar with the equipment, knows the age of it, they will do tests to determine, how effectively the compressor itself is working. They can measure certain current draw, voltages, that sort of thing, and make recommendations. Again, a compressor does not have an infinite lifespan, and you want to kind of get ahead of the curve And if the technician starts to recognize that there may be potential problems, potentially imminent, then, this is where they can make that recommendation before it becomes a big issue.
Excellent. Thank you so much. So let's move on now to fan failures, which can take comfort down levels quickly. Andrew, what's a clear sign that a fan or blower motor isn't working correctly?
For sure. So, if a blower is failing, obviously it's going to be where you simply have little or no airflow coming from the supply air vents itself. It's obviously very obvious at that point. There could be also burning, smell. This is electrical motor issue now, and you can smell that in the indoor space. There could be audible signs. Obviously squeaky bearing noise or blower bearings. These motors are generally air cooled. They rely on airflow to keep them operating within their designed air temperatures. If they do get plugged up, they can elevate the actual temperatures of the motor itself, and then cause that premature failure of the motor windings. Typically, as you can see in that image right there, it's about a 1 to 1.5 hour job to replace a motor or repair a blower assembly. So, that's something ultimately, can be avoided with regular planned maintenance.
Great point. Thank you. Gina, what can FMs do to help prevent fan or blower motor failures?
Yeah, this is an interesting one, because I would say that, somewhere in the neighborhood of 20-25% of the calls we receive are due to these types of issues, airflow issues, whether it's a belt-driven motor and the belt has not been replaced or installed improperly, things of that nature. So from an FM standpoint is, asking the right questions to whoever your HVAC provider is, asking them if they were on a maintenance visit, did you replace the belt? Did you align it correctly? Those types of things. If it's not belt driven, ask the question, did the motor need to be lubricated? Was it lubricated? How was the voltage? How was the amperage? Things of that nature. That tends to keep a tech focused on what they're supposed to be doing during either the service call or the preventative maintenance. And then another sign is, obviously, if you hear the noise factor. Generally, if you got bad bearings that go bad, or a belt is not aligned properly or damaged of some sort, it's going to be louder than typical. And my suggestion is, the minute you start to hear something a little bit abnormal, turn that thermostat off, shut the unit down, and then get an HVAC professional out there to take a look at it, because it'd prevent more. It'd be much cost effective to take care of a simple problem than it turn into a failed motor, or worst case scenario, a blower assembly goes bad. So I think that's what I would suggest the most.
Excellent. And Gino, I understand fan issues present a particular problem in restaurants. Why is that?
They do. Typically, restaurants, you got cooking equipment. Generally, those types of facilities have a lot of exhaust fans, things of that nature. And typically, the way those systems are designed, they work hand in hand. Your rooftop, the comfort, they're generally bringing in some sort of outdoor air to keep the pressure in the facility correct. And when things go unnoticed or not paid attention to, if that airflow or pressurization inside the space gets out of balance, that could cause problems for other equipment. Definitely uncomfortable for not only the staff but the customers, things of that nature. So it is, in my opinion, vitally important that when it comes to a preventative maintenance program, it's not only the rooftops, it's the exhaust fans, it's the kitchen hoods, things of that nature, I think, are all important. They all have some sort of motor, they all have some sort of bearings and belts and things of that nature, that all of that is being taken care of the way the manufacturer was meant to be taken care of.
Excellent. Thank you so much. So let's move on to the next one then. Gino, can you tell me about the signs of an HVAC failure due to electrical problems?
Electrical problems, probably the number one is, a tripped breaker. There's a lot of items that go into a breaker tripping. It could be weather related, thunderstorms, things of that nature, ComEd issues, but even other items that go into failures on the electrical side is through preventative maintenance, making sure there's some sort of component that needs to turn these items on. It starts with the thermostat to enable the rooftop to turn on cooling or heating. And then from there in the equipment, there's electrical components that turn on the compressor, turn on the blower motors, make the dampers open and close, those types of things. All those should be part of a proactive customized preventative maintenance that are being checked. Terminals, wiring terminals tightened, things of that nature should all be part of a good preventative maintenance program. Along with, as you start to see these components fail, that you bring them to the customer's attention so they could be addressed quickly before a major component failure. I would say the number one thing we come across are loose terminals. Loose terminals could wreak havoc on these components. And it needs to be a priority and part of the tasking through preventative maintenance. And then I would say weather is second. So check the breakers. If they're tripped, turn them on. If it trips again, then there's definitely an issue. Then I would contact an HVAC professional to come take a look at it from that point.
And I think when for example, when a compressor or blower motor is failing, from a runtime perspective, it can, you can see basically it's just simply not meeting heating or cooling set points. It could be working perfectly fine, and all of a sudden, you start to see a deviation away from set point. Could be an indicator of many different types of failures, within the system itself. Something that essentially really disrupting the main part or the control circuits of an RTU that won't allow it to come on, whether it's high voltage or low voltage. For example, when I think, prior to heating season, looking at a gas-fired rooftop, the burner and ignition system should be inspected. Like, for example, talk about a whole bunch of different electrical components, the venter motors, pressure switches, flame sensors. There are several electrical components that make up of a burner system, which all potentially could fail during the heating season. That just gives you an example of how highly integrated these are. And all it takes is just for one electrical component to fail. And then all of a sudden now you have either no heating or no cooling.
Excellent insights. Thank you so much. Gino, what can be done in terms of preventive maintenance here?
Yeah, preventative maintenance, it comes down to the tasking in the company is checking the contacts on these electrical components that are throughout the equipment, tightening the terminals, checking the pressure switches, the venter motors, the voltage that's going to all these components, the amperage that's going to all these components are all, it's not only valuable information, but it can give you a good idea of how the equipment is currently running. And then once the units are hitting that age level to where we need to start looking at budgeting for replacements, we could better educate the FMs on to when to start preparing the budget. So I think that's probably the most important part of it.
And I think, if you're monitoring thermostat set points with an EMS platform, you might see that the system itself is working perfectly fine for some time, but all of a sudden, in a couple of months into the heating season, systems running for 12, 14, 18 hours a day, this is typically when a failure is going to happen at this point. Systems under stress or just constantly running. So as much as a preventive maintenance can help, you still can't control or determine when components are going to fail. So that said, we continue to improve our MESA HQ platform. We will provide additional monitoring and data points to help, alert customers to potential issues sooner than later.
Excellent. Thank you so much. So let's move on to the next one and talk about the classic out of sight, out of mind issue, dirty coils. Gino, you touched on this earlier, but why are coil failures common and how can you detect the issue?
It's a long conversation, but in brief, a lot of times with rooftops, they're typically on roofs. FMs might not have the ability to get the roofs and things of that nature. What we find most common is that coils, they do need to be cleaned on an annual basis. And in some cases, depending on what state it is and things of that nature, you might have to deal with cottonwood and just natural debris that flies through the air will clog these coils up. And depending on the type of equipment, coils need to be cleaned differently. So there's coils that might be extra thick or have two sets of coils that need to be separated in order to be cleaned correctly. There's those types of things. So when you start to physically see that a coil is starting to gather debris on the coil, that's a visual sign that it needs to be cleaned sooner than later. And then you have the other hand on the refrigeration side. So if you have a restaurant, fast food facilities like that, a lot of times the condensing units might be on top of the walk-in coolers and freezers and things of that nature, which would be above a ceiling. Those coils tend to get dirtier a lot quicker. So one of the recommendations we make is on a quarterly visit, is that the coils are cleaned in those situations on a quarterly basis. And depending on how busy a facility might require more visits or cleaning. Rooftops, generally we see, once, if not twice a year, needs to be done properly, cleaning the coils properly based on the equipment type. That's about all I got on that one.
No, that's helpful. Thank you.
Yeah.
Andrew, anything to add in terms of preventive measures for maintaining HVAC coils?
Sure. So, if you have professional service contracts, making certain that when you are having the coils clean, request photos of, call it, before and after, just peace of mind to know that the job was done right and is not going to be a factor moving forward. As Gino had mentioned as well, depending on the exposure to the coil itself, whether evaporator or condenser, you do have to adjust the frequency of coil cleaning. For example, if we're talking about an outdoor condenser coil, depending, what kind of exposure that it gets to the outdoor air and how dirty it is, when it becomes excessively dirty and restricts the airflow, the unit itself can't do that normal or needed heat rejection, and of course then the overall cooling capacity is diminished and will definitely significantly impact the overall HVAC performance. When we think about evaporator coils, specifically to ensure that things are working correctly, after the maintenance, tracking your delta T between supply, return air, maybe measure the discharge air temperature after the evaporator coil. I like to use a digital psychrometer to measure that relative humidity in the space to ensure that, the evaporator is working correctly and it is effectively removing moisture in the indoor airspace.
Excellent. Thank you. And before we move on from this, just because, again, out of sight, out of mind, it could be easy to forget. Andrew, what's the impact of skipping just one cleaning cycle?
Sure. So I think it's really, better to main coils to maximize performance and avoid that, degradation over that 6 or 12-month planned maintenance cycle. Otherwise, it could potentially lead to higher maintenance costs down the road and potential issues that can be. And then at the same time, while a technician's on site doing the cleaning, it's an opportunity to detect any major issues or issues that can become a major issue that will lead to an emergency problem.
Excellent. Thank you so much. So let's move on to the fifth and final cause of HVAC failures we'll discuss today, the economizer, the unsung hero of efficiency. Gino, what are signs of an economizer failure?
Okay, economizer failures. This is a passion of mine. This is probably the number one issue that I find when we service rooftops. For whatever reason, we find them disconnected, inoperable, not sensing the right outdoor air temperature or indoor air temperature, humidity, and dry bulb temps. I would say the things that you could look out for is economizers generally serve two purposes. One, to help bring fresh air into a public facility, and number two, to limit the air conditioning or that compressor runtime when outdoor air is suitable to cool a space. And generally, there is an outdoor air sensor, outdoor air humidity sensor, and in some cases, there's indoor temperature and humidity sensors inside. So number one is if you notice that if it's a colder day, fall day, winter day, and you hear your compressor running or you see your compressor running and you know that you have an economizer installed, that could be a number one sign something is not correct. And we should look at it definitely through the maintenance. It definitely should be part of the tasking to check that operation, that the damper actuators are opening and closing correctly. A common issue that we come across quite a bit is there are filters that are catching large debris from entering the economizer section. Is making sure those are clean. Those will clog up just as bad as a coil and cause undue stress on the blower motor and things of that nature. It will also, in combination with improper filter changes, could cause damage and in some cases clog up the evaporator coil, which is the coil inside the unit. Generally, to conserve running time, operational costs, and things of that nature, a good working economizer to me is essential to any commercial space, regardless of what type it is.
Excellent. Thank you so much. Andrew, how can FMs maintain an economizer and maximize its useful life?
Sure. So definitely annual economizer function testing, making certain, for example, is the enthalpy controller working correctly? So really taking advantage of the free cooling when it's available. The economizer and all the sensors do kind of operate in a harsh environment. So making certain that, outdoor, indoor air sensors are calibrated, that they are feeding that correct information back to the enthalpy controller, and of course, things should be documented as well as part of that preventative maintenance report. From a runtime perspective, typically an economizer is usually tied to the first stage of a cooling system, being if you have a two-stage system. During shoulder seasons with lower ambience where free cooling can be utilized, are they seeing a reduction in that second stage of mechanical cooling? So if the enthalpy controller is not working, and you're not taking advantage of first stage free cooling, that will result in more frequent second stage mechanical cooling. So that would be a telltale sign in the runtime reports.
Excellent. Thank you. And for either one of you, why are economizers rarely tested after they're installed?
I'm not sure on that one. We do extensive training with all of our service techs when it comes to economizer operations, because the older the equipment is, with the older style controls, they're a little bit easier. Nowadays with new equipment, a lot of that is being done through digital type control boards and things of that nature in the equipment. So nowadays there's a lot more of a need for extensive training from a service technician standpoint. So the answer to that question is a difficult one. So it's a well-qualified technician, there should be absolutely no issues on that particular tech being able to troubleshoot properly and maintain it to make sure that it's running appropriately throughout the lifespan of the equipment.
Yeah, I think, to Gino's point as well, there's the mechanical side of an economizer, then there's the actual controls part. And this control part can be complicated, fairly high-tech, digital control, digital display. I think there may be a lack of expertise or understanding how they work or how they're set up. Or if they need to be calibrated, how do you even access the functionality of the enthalpy controller itself? And I mean, at the same time, if there's no documentation to reference on site, is the technician going to take the necessary time to ensure that, the economizer is working correctly?
Excellent. Thank you both so much. So we've covered a lot of ground today regarding HVAC failures and their warning signs. So now let's bring this all together for our audience. What steps should facilities teams take today to stay on top of their HVAC equipment and performance? Gino?
Yeah, I would say be aware of and be as proactive as possible. Like we talked about earlier, do a daily walk, check your thermostats. Look into EMS type system if you don't currently have one. Hear unusual noises. Get a hold of your HVAC professional. Ask the right questions when an HVAC professional is on site. Take that full visual approach and remember that preventative maintenance is not just changing filters. There's a whole lot that goes into it in order to maintain that equipment for as long as possible, to keep those energy costs as low as possible and extend the life of the equipment as much as possible.
And Andrew, what would you recommend?
Yeah, so I think really to help organize what preventive maintenance should be done, MISA, we have created a handy HVAC health checklist that the audience can download for free from the MISA HQ website. Today we have discussed a lot throughout our conversations. Having more data and insights into your HVAC system, helps manage or provide a window into the signs of potential problems or failures happening. With the energy management system like MISA HQ, facility managers can monitor this in real time. They can be alerted when there is a potential problem happening. And again, this doesn't really matter, where these locations are. Everything can be monitored remotely. And so, yeah, I mean, I would recommend that, take the opportunity to schedule a free demo of MISA HQ and really see the benefits of how this can help your organization.
Excellent. Thank you. And before we jump into some Q&A with our audience, I want to ask each of you to share just one thing that you wish every facilities manager would start doing tomorrow. So Gino, we'll start with you.
If I would say if you feel that there's a need that something is not working properly, call sooner than later would probably be the first thing. A lot of times we find that they wait a little too much of an extended period of time. And by the time that phone call is made and we get out there, it's a lot more repairs are needed and the costs tend to be a little bit much higher at that point. So be more proactive when you call, before you call, or when you call that HVAC professional out.
Well said. Andrew?
Yeah, I agree with you, and I think, from an EMS perspective, it's kind of should be a daily routine, when you first sit down and opening up your laptop and, opening up MISA HQ, the very first thing, to me, it would be is, look at the portfolio and understand, if you have any sort of active alerts happening, and, whether, and to determine or prioritize, are they something that requires immediate attention, or is it something that you can plan ahead as well? So it's just building it into your daily routine and really trying to, emphasize being proactive rather than reactive.
Excellent. Well, thank you, Gino and Andrew, for this excellent conversation. As we learned today, HVAC trouble calls are a big source of headaches in a facility manager's day-to-day, and they can cause costly downtime and repairs. By recognizing the early warning signs and conducting preventive maintenance and proactive monitoring, you can reduce the likelihood of major HVAC failures and operational downtime at your sites. So in the time that we have remaining, I'd love to take some questions from our audience. And Andrew, I'll pose these to you to start, but Gino, then just feel free to jump in. Our first one said, you compared the costs of planned versus emergency maintenance at the beginning of the chat. Can you estimate typical costs for the HVAC failures you described to give FMs a sense of what to expect if they do have to bring in a technician?
Yeah, great question. I mean, numbers always help make a situation more tangible in what you're dealing with. So we actually compiled an estimated repair cost for common HVAC failures. Again, this can be something that's downloaded from the MESA HVAC downtime prevention guide. And this also goes into kind of greater depth into a little bit more detail of the cause of HVAC failures.
Excellent. Do you know anything to add?
Yeah, no, I agree. The sooner, the more proactive an FM can be with being aware that there potentially could be an issue. You definitely would want to reach out to your HVAC contractor as early in the day as possible. They keep those labor costs down. When you look at the emergency rates or a weekend or holiday, you could almost be looking at double those labor rates on top of availability of parts needed and things of that nature. It's always going to be more cost effective to get those parts during the day than it is at night or over a weekend and things of that nature. And then, as always, try to prevent component failures through a proper maintenance program on the equipment.
Perfect. Thank you. Our next question says, for an energy management system to work successfully, what IT equipment or sensor types must be installed on the sites you're monitoring?
Yeah, that's a good question for sure. So I know from firsthand experience, working with IT teams can be very challenging, and not something that we really want technicians to deal with as well. I mean, we really want them to focus on what their expertise level or what they're experts at, and not have to deal with complicated network configuration or dealing with IT people. Obviously, this can have an impact on the deployment. So thermostats, the thermostats in each of the, call it EMS in a box, these arrive as prepared to a cellular router. So again, I mentioned no complicated network configuration required. And when we look at adding additional sensors, for example, supply return air sensors, or maybe something to measure a refrigeration system itself, these sensors also have dedicated communication hubs that will tie directly into the cellular router. So it's really all plug and play. So that would be that. Yeah.
Yeah, nowadays, to go with what Andrew was saying, nowadays, as far as that IT EMS relationship, it's amazing some of the products that are out there now, and how you're able to communicate with the equipment in all different fashions through products like the MESA unit.
Excellent. I think we've got time for one more question. So how does an energy management system deliver ROI?
For sure. Definitely, a key factor for sure. So definitely reducing energy consumption, using occupied and unoccupied schedule set points. Also factoring in, we want to also think about, how do we restrict or limit unauthorized access to the thermostats themselves, either using full or partial lockouts. If you do provide partial lockouts, giving the on-site staff the ability to apply manual overrides, for example. You want to limit the upper or lower temperature ranges that can be selected, so they're not jacking the temperature down or way up high, causing excessive run times. As for like statutory holidays or anything that you know that's going to come up outside of the normal working weekly schedules, you can provide a scheduled calendar event. Basically, it's going to override what would be the normal schedule for that 24-hour period. And I think additionally as well, operational benefits can include reduced work orders, investigation time, potentially fewer truck rolls, and ultimately what we're all shooting for is, extended equipment life.
Yeah, I agree. One of the most common things that we come across, especially with facilities that have multiple thermostats, multiple locations and things of that nature, is the scheduling. And I think there's a huge ROI on being able to be as proactive as possible with your occupied, unoccupied, scheduling along with the holidays and things of that nature if the facility's not open during a holiday. But we see that quite often where they're just running 24/7 and normal occupied, whether they're opened or closed. So I think there's a huge potential there for being proactive with that scheduling.
Excellent. Thank you so much. That's all the time that we have today. Thank you again, Andrew and Gino, for sharing your expertise and tips. And a big thank you to our audience for joining us today. We hope you found this conversation helpful. Have a wonderful day.
Thank you.
Thank you.